Hello and welcome, my dear students. Today we are here again for delivering a new lecture, and actually, it is the first lecture of 12th class physics covering the CBSE syllabus. So, the first unit which we will start today is electrostatics. What is electrostatics? Before going into detail of this unit, I will give you some example which will make you clear about the concept of the electrostatics. You might have seen when you are in your class, you are doing some sort of, you are actually free and you are doing some extra work, like you are taking a pen and you are rubbing in your dry hair, and then you are putting it near the small pieces of paper. You see that the papers get attracted towards that pen, and you are astonished at what actually is happening, why the pen which you have rubbed in your hair, dry hair, is attracting the small pieces of paper. What is actually happening there? So this is nothing but something related to this. Okay, one another example. Nowadays you might have seen that whenever you are sitting on a sofa, okay, particularly the sofa set with some cloth material, and then after some time when you stand up from that sofa and you touch somebody which is at another point, then you see that there is a spark. Okay, you feel some sort of electric current. That is for a short moment, very short moment. So that is also due to this phenomena. So what is this actually? Why this is happening? We will go into the physics of the phenomena you have seen in your daily life. So the word electrostatics come from two words. One is electro, which is nothing but charge actually, and static mean at rest. When we say that something is static, static mean at rest. When we say dynamic, it means it is in motion. Okay, two things are there. So study of charges at rest is nothing but electrostatic. Now, when I told you that you take a pen or a comb, whatever you have, a plastic body, and rub it in your dry hair, and then take some small pieces of papers and bring your pen near to that papers, you will see that the papers get attracted towards this pen. So when you are rubbing your hair, you are basically making a friction, right? Friction between your hair and the pen, right? So something at that point might happen, due to which the pen is attracting the pieces of paper. When you are sitting on a sofa for some time, and when you are standing up, and you see that when you touch somebody, you see that there is a sort of small impulse of current. You feel a small type of, you can say, current feeling. Why it is there? This is because of electrostatics, charges at rest. Okay, so to get into more clarification of this idea, let us take a glass rod, right? This is a glass rod. Okay, now take a silk cloth. Which type of cloth? Silk. You can get it at your home. You just take this and rub this on silk cloth. Okay, now for some time, say for 2 to 3 minutes, then take a stand and take a silk thread and suspend it. Suspend the rod like this glass rod. Now similarly, you take one another silk cloth and a glass rod, rub it on this. Now bring this glass rod near to this. You will see that this glass rod repels, it goes away when you bring this towards this. So there is something, it is sure. Now you take a plastic pen and bring it near to this. You will see that it is getting attracted towards the pen. So again there is something. You know what is actually there? There is a transfer of charge when you rub this glass rod on the silk cloth or pen in your hair, or when you're sitting on the sofa, there is a rubbing between your body and the sofa surface. So this rubbing means friction. That's why the charges produced by friction is also known as frictional electricity, right? Sometime you may hear this word also, frictional electricity. This electricity and electrostatics, static electricity, these are all same, right? So frictional electricity mean when you rub something with another thing, there is a transfer of charge from one body to another. We will see why it is happening actually, what is the physics behind that. Okay, so the frictional electricity is not a new thing. You have seen it from your childhood even. Okay, you might have done all this pen, and you have seen nowadays you are feeling very for a very short duration a kind of current type feeling when you are going into a car, you are driving, and when you are out of the car, you feel kind of current for a short moment. This is all due to frictional electricity. Nothing new, no 5G radiation, no 4G radiation, all are dramas. Nothing is there, no problem is there actually from 5G radiation. It is only frictional electricity, which is prominent in the days when there is some dryness in the atmosphere, right? If there is dryness, you will see this phenomena. It is prominent in those days, that's all. So why it is actually happening? What is there which makes the glass rod, when it is rubbed on silk or a pen is rubbed in dry hair, it attacks a piece of paper? What actually happens? Actually, we have to see that what actually happening there, right? What is actually happening during that process is very simple. You know that in this whole universe, everything is made up of atoms, like, and whatever you see in this whole universe is called as matter. Matter is nothing that occupies space. Actually, now I'm going to tell you what is the physics behind frictional electricity, what is the physics behind static electricity or electrostatics. That I'm going to explain, right? So whatever you see in this whole universe with you, which you can touch with your hair, with your hands, is nothing but matter, right? Now this matter is made up of atoms. Scientists gave a conclusion many years ago that the matter consists of atoms, right? Which you cannot see with your naked eye, right? Because the size of atom is in the power of 10 to power minus 10 meter, right? Then the atoms are further divided into elementary particles, protons, electrons, and neutrons. And to your utter surprise, these elementary particles are further subdivided into smaller particles called quarks. However, our discussion today is up to this point only. We will not discuss quarks. We will discuss quarks in some another lecture, because that is something strange, something charming. Like these are the particles named also, elementary particles. We will discuss these quarks in detail in another lecture. So whatever we see with our eyes is made up of atoms. Like you see a phone, you see a press, you see a bed, you see your father, mother, parents, anything which you can see with your eyes is made up of atoms. The smaller particle is atoms, right? And that atoms uh, are having the basic elementary particles, protons, electrons, and neutrons, right? So if you see, this is an atom, say this is some atom. The central part of the atom is nothing but nucleus. You might be knowing, this is not a strange thing for you. Okay, and in this nucleus there are protons and neutrons, and around the nucleus there are some shells and subshells also, right? Now in these shells, KLMN, right? I have given the name KLMN. You see, the electrons are revolving around the nucleus. These are electrons in the fixed orbits, right? According to some theory. So, the total number of protons in the nucleus is equal to total number of electrons. And you know, the total charge on the protons is positive charge. Charge carried by proton is positive, right? And electron carry negative charge. If I say there are 5 protons in the nucleus, so 5 electrons will be there outside the nucleus, revolving around the nucleus in different orbits. Like different planets move around the sun. Similarly, these electrons move around the nucleus. Nucleus is kind of sun, you can say. And these electrons are like planets which are revolving around the earth, and here they are revolving around the nucleus. Okay, and this is the atom, right? Now if you see, neutron have no charge. Neutron have no charge, right? Neutron have no charge. Proton have positive charge. Electrons have negative charge. And I also told you the number of protons in the nucleus is always equal to number of electrons in the outer shells. Okay, so if you see the atom as a whole, it is electrically neutral. Why? 5 protons are there, 5 positive charges are there, and 5 negative charges are there. These get cancelled with each other. So the overall charge on the atom, overall electrical charge on atom is neutrality, neutral. Atom is electrically neutral. No charge on the atom exists. So now what is actually happening? Suppose this is a duster, okay, and when I'm holding it, I do not feel any type of current, any type of kind of shock. Why? Because it is a matter, right? Take the example what I am told you. Now if you look this matter under an electron microscope, you will see that it is consisted of matter, atoms. And when these atoms, if you see these atoms under the microscope, you will see that not a simple microscope, of course, electron microscope will be required. And if you see that these atoms, you will see that a smaller particle of atoms are protons, electrons, and neutrons, right? Now, atom as a whole is electrically neutral because number of proton in the nucleus equals to number of electrons. So whole charge get cancelled, neutron has no charge, so atom as a whole is electrically neutral. That's why it is neutral. I'm not feeling any kind of shock from this. But if by any chance, by any method, I rub this with some another thing, like it's a glass rod, which I told you, the glass rod atoms are electrically neutral, so glass rod is neutral. Now you rub this glass rod, this is a glass rod, you rub this glass rod with silk. Now when you take the cloth of silk, this silk is also matter. It is made up of atoms, and atoms of the silk are having elementary particles proton, electron, neutrons, and same number of protons in the silk atom in the nucleus is equal to number of electron in the silk atoms shells, in subshells. So the total charge on silk is 0, no charge is there, right? So it is electrically neutral. Now when you rub this with this, when you rub glass rod, this is glass rod, you rub this with silk, what actually happens? Before going into that, I will tell you one thing. That term is work function, right? You must be knowing this term to understand this. What is work function? Work function is the minimum amount of energy required to remove the electron from the surface of any matter. Like if you want to, it is made up of atom. Now this is matter made up of atom made up of elementary particle, proton, electron, neutrons. Electrons are outside. This electron is bound with the nucleus with smaller energy. This is bound with nucleus with more energy. This is with more energy and this is more energy. Like you consider nucleus as your parents, right? If you are near to parents, you are staying with parents, the bond between you and parents is more. Similarly, this electron, which is near to nucleus in K shell, is having more attachment. So more energy is required to remove this electron out of the atom. You cannot remove easily. But when you go outward, like this electron is staying in US. Like it, I mean, if it is a sun, it is staying in US, and this is a parent. So the attachment between this and this will be smaller than this boy. So this electron will be loosely bound in the nucleus with the nucleus. So there, because nucleus has positive charge, electron has negative charge. So there is an attraction. Okay, this is Coulomb's interaction. So when there is an interaction between nucleus proton and electrons, so there is energy which binds them here. So minimum amount of energy which we have to give to these electrons to eject them out, to so that the electrons are moved out of the surface of this pen or rod or anything else, you have to give them some energy. That minimum amount of energy is called work function. If for a substance work function is small, what does it mean? It is a good news or bad news? It's a good news. If the work function is small, it means you have to give very small energy to the electrons to pull that out of the atom. And if work function is large, it means you have to give large energy, much more energy to remove this electron from the surface of the matter, right? So when the glass rod is rubbed with silk, let us see what happens actually. When the glass rod is rubbed with silk, the electrons, the outermost electrons of the glass rod, which are having very less work function, mean very less energy is required for the electrons of glass rod, these electrons, outer shell electrons, loosely bound electrons, these electrons will get transferred here, right? And it will have lesser electrons. Lesser electrons mean more positive charge, right? So now the glass rod has excess positive charge and silk rod has excess, silk cloth has excess negative charge. You just see. So there is a transfer of charge from glass rod to silk. Only electrons are transferred here, which are loosely bound, which are having less work function. Okay, very low value of work function. So now the silk cloth becomes negatively charged, right? Why negatively? Because it is having excess electron. Electron is having negative charge. So it is now negatively charged. And glass rod becomes positively charged, right? This is the reason. Now what happens? There are two types of charges, positive charge and negative charge. And when you bring similar kind of glass rod here near to it, like this, then what will happen? This glass rod will also have excess positive charge. Positive repel each other. There is an old saying, positive repel. This is a fundamental law of electrostatic. The positive charges and positive charges mean like charges, same kind of charges repel each other, right? And opposite kind of charges attract each other, right? If it is a positive charge and it is negative charge, what will be there? There will be attraction. And if the charges are same, what will be there? Repulsion. Like negative repel each other, positive repel each other, and the different charges, unlike charges, attract each other. There will be attraction. Like so what happens actually? This glass rod is now having positive charge. Take another glass rod which is having more, say again positive charge, positive repel each other. This is the reason that when you are sitting on a sofa, okay, You are today go home, sit on a sofa, and particularly that sofa which is having a cloth surface, right? Sit it for some time and rub yourself on the sofa, right? Then after that you must be wearing shoes, that is must, because as an insulation. Now when you stand up from sofa, go and touch somebody which is at some farther point from you, then you will see that there is charge, there is spark. What is that actually? Because when you're rubbing sofa, due to rubbing, due to friction gives energy. Now when you are rubbing, you are giving energy to that, okay, and you are removing electrons from the sofa set, because sofa set is a matter, it is having atoms. So atoms are having proton, electron, neutrons. So the outermost electrons of the sofa's atom, you are pulling them with your body, and they are get attached to your body. And when you stand up from the sofa and go somewhere and touch somebody, you see that the excess electron which you collected from that sofa, they get transferred to that, because that is at another potential. So there will be a spark. Spark means there will be kind of shock for movement, because now these electron will be transferred to that body, and there will be a kind of positive spark you will see. Maybe that person may have positive charge and this is negative charge. So positive, negative when combined, they give a kind of shot, mean kind of energy. Okay, so this is the phenomena, this is the basic physics which is behind electrostatics, right? So what we learned today, that charges are of two types, one is positive charge, another is negative charge, okay. And when we say negative charge, it is basically, we denote it in the form of electron, like electron is having negative charge and proton is having positive charge, neutron have no charge, right? So we learned today that frictional electricity is only produced due to rubbing, due to friction between the two bodies, and due to friction or rubbing, the transfer of charge take place, right? This transfer of charge is the reason, positive reason behind frictional electricity, and nothing new in it. It is an old phenomena, very old, right from 500 BC to 1600 AD. It was it was a normal thing. Okay, so this is all about the basics of electrostatics, the static electricity, how static electricity is produced and why it is produced. Thank you very much.